All right, so this is the second video on the definite integral, and remember that symbol that we see here. It's almost like a stretched S. And if you play like I would say like violin or cello, or if you know what those look like, those or guitar, those instruments, like those, it kind of looks like the part that's in the like part of the acoustic part of the guitar where you see the design there. So that's kind of cool. Okay, so I'm calling this two kinds of negative. So remember, this means find the area under the curve up to the x-axis. But what if you're below, right? So if I look here, there we go. So if I look right here from 0 to 4, like my curve is below the x-axis, not above. So it still takes up space, right? It's still a 4 by 4 triangle, so has a space, takes up 8 units of area. But because that area is already below the x-axis, I'm going to give that almost like a displacement or connotation that it's negative. And it's sort of like when we think about velocity under the curve, we think about that as being negative as well. So when you're underneath, you have a negative area. Now, you do a double take on part B, 10 to 5, not 5 to 10. 10 to 5. If you start at the right and go back to the left, right? So from 10 to 10, 9, 8, 7, 6, 5. I'll pretend to set it 4, just make it nicer, right? So 10 to 4. So I still have space here. It's a 6 by 1, 2, 3, 4, 5, 6. So 6 by 6 is 36, so it has a space of 18. But because we're starting at 10 and going backwards to 4, remember I changed it to a 4, that's going to have another negative connotation because you're reading it right to left as opposed to left to right. So we say that's negative 18. So those are the two kinds of negatives you can have. If the area exists below the x-axis, it's negative. If the area, or if your bounds go right to left, it's negative. Now, this next one says from negative 4 to negative 2. So let's see, negative 4, just here, to negative 2. Which is there. And so there's nothing out of the ordinary here. It's just 2 by 4. So that's 2 by 4 is 8. Half of that is 4. So it has an area of 4. So I guess I'm contrasting that with, it doesn't matter if you lie to the left of the y-axis. It just matters do you lie underneath the y-axis for that negative area. Okay, 2 to 0. So now we sort of have both negatives, right? So we have from 2 to 0. So from 2 back to 0. So right now I know that takes up, again, it's a space of 4. Because the bounds are backwards, it's negative. Because I'm below the x-axis, it's negative. So we do get a case where the two negatives cancel and becomes a positive 4. Okay, negative 2 to 2. So now when I look at here, from negative 2 to 2, I want this area that's bound under this curve. Remember, you're always drawing to the x-axis. And this area here, which is drawn to the x-axis as well. Well, it's equal displacement. The amount above equals the amount below. So we get 0. So we have no area. Our net change is 0, even though there's 4 units above and 4 units below. The one's positive connotation, one's negative connotation, so they would cancel. And then here, 10 backwards to 0. So, 10 backwards to 0. So we're starting at 10. We're going all the way back to 0. So we already know my final answer is going to be negative. So going backwards. And then this area here, we calculated to be a negative 8. This area here, we calculated to be 18. So negative 8 plus 18 is 10, but it becomes a negative 10 because of the fact that we're going backwards. You could have also treated each of them separately. So like this would have been negative 18 because it's going backwards. This would have been a negative 8, so positive 8. And again, you still got negative 10. So watch for those negative values. Okay, and then another piece of terminology is called an accumulation function, something that collects area, accumulates. Think about like accumulating snow. right? It collects snow, how much snow has fallen over time, how much rainfall has fallen over time. And the only difference that we're going to do, or the thing that we're adding to this, is that top bound, we're going to call it a variable. And it's going to be based on this function out here. So we're just going to create a brand new function that changes the top bound. And the bottom bound, C, C for constant, like that's going to be a fixed point. That's a constant or a fixed starting point. And then, so fixed starting point. And please notice that the difference of variables, your area under the curve function here, right? Like that's one variable, which will also match this here suspiciously, right, with derivatives. But then out in front, the whatever you define this to be, like that variable will match up there. Okay, so again, so an accumulation function is, again, if you're just going to be analyzing the same graph and having the same starting point, then it'll become much more efficient to represent it as an accumulation function. And we'll go through a couple of examples like that in just a second. But just kind of fill this out. Area will always be measured. Wow, area will always be measured under the curve, and we'll use the x-axis as the boundary, okay? Like displacement, though, accumulation functions can measure negative area in two ways. So if your figure lies below the x-axis, or if you're moving right to left, same thing. Region below x-axis. So we might as well fill this in. Or bounds move right to left. So you're going almost like backwards in time. Okay, so, but really, that's the only new piece. It's look at your problems. They look, oh, g of 2. Oh, what is g? Oh, g is this accumulation function. G of 2 says we're starting at 0, and because the t is here and the t is up there, so we put a 2 there. Oh, so g of 2 says find the area from 0 to 2 under the curve of f of x dx. So and since like g of 4 says, oh, find the area under the curve starting at 0 but go up to 4. Of the function f of x dx. So if you're repeatedly going to be starting at 0, and now how much to 2, how much to 4, how much to 6, right? How much to 8? So then it just, again, is shorthand. So you don't have to keep writing this integral symbol. You're sort of just saying, well, if I'm always having the same starting point and the same curve, I can efficiently write down what I'm looking for. So how much area is from 0 out to 2? Well, it's a 2 by 2 triangle. Half of that would be 2. And if I want to go all the way out to 4, so I have this 2, and then I continue to go out to 4. So I've added 2 more units of area. So I have 4. And then this says start at 0 and go out to 6. And you don't necessarily have to keep writing this integral from 0 to 6 of f of x dx, but I just want to make you aware that, the 6 that you're putting here matches the 6 that's up there, but the starting point is still 0. So then we are accumulating, oh, look, we've already accumulated 4, and then up to 6, there's 2 more units, so that's 6. It's kind of like a nice little 1-to-1 ratio here. And then how about 8? So again, we're accumulating all the way to here, so we're adding 2 more units, so that gives a total of 8. Now, g of 0, so this tells us start at 0 and end at 0, and how much area is under the curve. Well, if you don't go anywhere, right, that means your area is 0. So then I have no accumulated area. And then g of 10, so again, thinking back, well, from 0 out to 8, we've accumulated 8, and then we're going to be accumulating, I guess red would be good, appropriate, 2 more units of area, but it's below the x-axis. So that's going to serve as a -2 displacement. So I have my 8 from before, take away 2 is equal to 6. Okay. Now, let's change up the game. Let's start somewhere else. Let's start at 4. So it's the same idea. You're starting at 4 and now accumulate area. And the thing is that, if this makes sense, you could fill this out and then check your work at the end of the video. Or if, you want to follow along, that's fine too. So at 4, oh, sorry, I'll erase this out. 4 becomes my starting point. So now I'm starting at 4, which is right here. Okay. So then when it says find the area starting at 4 and going to 4, because the bounds match, right, from 4 to 4 of f of x, how much area is under that curve? Just 0, because you haven't got any. And then this says find the area from 4 out to 6 of the function. And again, you don't have to write this out necessarily. You could just think about that in your head. So then that triangle had an area of 2, if I remember. And then this is going from 4 to 8. So again, you don't have to write this out. This is the whole point of the accumulation function, is that shorthand, you always start at the same point. So that has an area of 4. And g of 10, that member that started bringing negative area back. So I believe that would be area of 2. And we can make a quick visual starting here. So you have an area of 4, but then we take away the 2. 4 minus 2 has a total displacement of 2. And then, g of 2. So now we're going backwards. We're starting at 4. We're going back to 2. So remember, that's one of our forms of negative. And so 4 back to 2, so it's above the x-axis, so it's a distance of 2 or displacement of 2, but going backwards with the bounds makes that negative 2. And then going all the way back to 0, that's 2 more in that direction, so it's negative 4. G of negative 2, again, starting at 4, going backwards to negative 2. So then as you start to go backwards, so we have negative 2, negative 4, but then it becomes like a negative 2. So you're actually adding 2. So adding 2 more units to that becomes negative 2. And then negative 4 will give us actually 0 area, because we'll have equal displacements. Again, we're starting at 4. We're going back here, adding up this area that's negative 4. These are double negative 4s, which is positive 4. So our displacement is equal, so we get 0 area. Okay. Let's type that in there. And I think there's just one more example here. And again, you could try this on your own and then fill in the missing pieces. We're starting at 2, which is right here. And let's just accumulate area. So g of 2. From 2 to 2, the bounds are the same. Area is 0. Okay, 2 to 4. So 2, 3, 4. We're going this direction, but it's below the x-axis, so it's negative 2. G of 6. So we're starting at 2. We're going out to 6, which is right here. Equal displacement. Area is 0. G of 8. So now, since I already know that this is 0 and I'm continuing to go, I just have to add this new piece right here. That's another thing of an accumulation function. You already have known how much you've changed, so now just add on to that. That's a 2 by 4. That's half of 8, which is 4. G of 10, continue, adding 4 more, so that's 8. And then g of 0, again, just reminding us that when we go backwards, we get negative area displacement, and that would be negative 4. Okay, so again, concept-wise, I'm hoping not too difficult, just interpreting that symbol to mean find area.